Now that we understand how to count valence electrons, let's go through and see how we can draw Lewis structures by a systematic approach. Now, the thing to remember about this is that this is a stepwise way to be able to always draw Lewis diagrams. 1. Count the total number of valence electrons available. For instance, hydrogen has 1, carbon has 4, and oxygen has 6. Number 2. Calculate the total number of electrons that would be needed if each atom had its own Nobel gas shell of electrons around it. For instance, hydrogen needs 2, carbon needs 8, and oxygen needs 8. And the same for heavier elements. Number 3, subtract the number in step 1 from the number in step 2. This is the number of shared or bonding electrons present. Step 4, assign 2 bonding electrons 1 pair to each bond in the molecule or ion. Step 5, if bonding electrons remain, assign them in pairs by making some of the bonds double or triple. 6, assign the remaining electrons as lone pairs to the atoms, giving octets to all atoms except hydrogen, who only wants 2 electrons. 7, determine the formal charge on each atom and write it next to that atom. And then 8, the best Lewis structure will have the least number of atoms with a non-zero formal charge. All right, let's talk a little bit about the formal charge. So we are going to use formal charge to determine if you have the best Lewis dot structure. All right, so the formula for figuring out formal charge is formal charge equals the number of valence electrons minus the number of electrons in lone pair minus a half the number of electrons in bonding pair. So for instance, for H2, the Lewis structure is hydrogen, single bond hydrogen. The formal charge on hydrogen is hydrogen comes in with 1. There are no lone pairs, minus 0. Minus a half, there's 2 electrons in bonding. That equals 0. The smaller formal charges, positive or negative, are preferable to larger ones. The same non-zero formal charges on adjacent atoms are not preferred. And 3, a more negative formal charge should reside on a more electronegative atom. All right. The other thing about formal charges is the sum of formal charges on an individual atoms must equal to the actual charge on the species. The sum is equal to 0 for a molecule, and the sum is equal to the ionic charge on an ion. All right, so here are our lists, our systematic way for determining the Lewis structures, step by step. Now, sometimes you can actually look at a structure and be able to determine it by inspection, for instance, guessing, and be able to not have to employ the systematic approach. The thing to remember about the systematic approach is that it will always work. So let's talk a little bit about formal charge before we go do some examples. So for the molecule H3CnHO-1, determine which of the following structures is most likely. Structure 1 has 0 formal charge on all atoms except for oxygen. Oxygen has a -1. And structure 2, there are 0 formal charges on all atoms except for -1 on nitrogen. Now, which atom do you think is more likely to have a -1 charge? Would it be oxygen or would it be nitrogen? The correct answer is oxygen. Oxygen is more electronegative than nitrogen, so you would expect that the structure number 1 is more likely than structure number 2. And in fact, you would be correct. Structure number 2 is the most likely structure for this particular molecule. All right, let's work through some sample problems, and then we will do some more practice offline. 1. Use the systematic approach to draw the Lewis dot structure for methane. Assign the formal charges to all the atoms, and then draw the Lewis structure. Here's our 6 steps, and we're going to go through and work the problem. So step 1 says, how many valence electrons do we have? Well, looking at the periodic table, carbon has 4, hydrogen has 1 each, so it's 4 plus 4 equals 8. Step 2, the number of electrons if each atom had a Nobel gas configuration. Well, that means that carbon is going to have 8, and each of the hydrogens need 2, so 8 plus 4 times 2 equals 16. Now, if I take 16 minus 8, that gives me a total of 8. That means we have 8 bonding electrons. 8 divided by 2 means that we have 4 bonds. Now, we started with 8. We've used 8. Are there any bonding electrons remaining? No. Do we have any valence electrons remaining? No. So our structure is carbon with single bonds to hydrogen. Now, you could have probably done this without doing the systematic approach, but this example is just designed to give you an idea of how to work it. All right, so let's check our formal charges and see if we're good. All right, so formal charge of carbon. Carbon comes from group 1. We have no lone pairs. We have 8 bonding, so a half of 8 equals 0. Formal charge of hydrogen is 1 minus 0 minus half of 2. So that means our Lewis structure is good. So all the formal charges are 0. So there are 2 possible ways to draw the structure. We can have it with our lines to represent our lone pair, our bonding pairs, or we can have dots. It does not matter which one you use. All right, let's do a sample problem number 2. We're going to draw a Lewis dot diagram for carbon monoxide, CO. We're going to assign formal charges to all the atoms, and we're going to draw the Lewis structure. So we are looking at CO. All right, number of valence electrons. Carbon has 4, oxygen has 6, to give us a total of 10. Step number 2, the number of electrons if each atom has its own noble gas configuration. Well, carbon and oxygen both want 8, so it's 2 times 8, which equals 16. And now step 3 says subtract step 1 from step 2 to give you the number of bonding electrons. 16 minus 10 equals 6. That means we have 6 bonding electrons. 6 divided by 2 equals 3. So there are 3 bonding electrons. So now we can draw our structure. We start off with 1, and that only accounts for 2 electrons, but there are 6 bonding electrons, multiple bonds in there. That will take care of our triple. So yes, we started with 6, so 4 bonding electrons left. Since there is only 1 bond for carbon-oxygen, there must be a triple bond formed between carbon and oxygen. The valence electrons. So we used up 6 in bonding, and we started with 10, so that means there's 4 left over. So we shall have to put lone pairs. So to determine who gets the electrons, check to see who has an octet already. So looking at carbon, carbon has 6, oxygen has 6. We have 2 sets of lone pairs. Now we can put each a lone pair on carbon and a lone pair of oxygen, and there is our structure. So now let's assign formal charge to check on our structure. Formal charge, 4 minus 2 equals a half of 6 equals a minus 1 on carbon. And for oxygen, 6 minus 2 minus a half of 6 equals a plus 1. Lewis structure is good. We have 2 atoms. They both have a plus 1 and a minus 1. So there are 2 possible ways to draw the structure, with lines or with dots. And you're like, why don't we get rid of our minuses? There's no other way to be able to draw this structure to get rid of those minuses. The third rule of formal charge is a more negative formal charge should reside on a more electronegative atom. So you're like, carbon is not more electronegative than the oxygen. Oxygen is. But in this particular example, if we give the negative formal charge on oxygen, oxygen will have greater than an octet. So for this one, it's more important that each of the atoms have octets, and then we will deal with the formal charge. So for carbon monoxide, octet is more important than formal charge. Draw a Lewis dot diagram for thionyl chloride, SOCl2. Assign the formal charges of all the atoms and draw the Lewis structure. First problem, who goes in the middle, S, O, or Cl? Well, we can look at the ionization energy to decide. The ionization energy of oxygen is 1314 kilojoules per mole. For sulfur, it's 1,000, and chlorine is 1251 kilojoules per mole. So the idea is you put sulfur in the middle because it's got the lowest ionization energy. So the rule of thumb is pick the element that's got the lowest ionization energy and put it in the middle. So now we've got our structure, our skeletal structure, with the sulfur in the middle and the chlorine, and the oxygen on either sides. Let's go through and do the problem systematically. Step 1, the number of valence electrons. Sulfur has 6, oxygen has 6, each chlorine has 7. 6 plus 2 times 7 equals 26. So there are 4 atoms. If each one of them had a noble gas configuration, the total would be 32. And now we can do 32 minus 26 equals 6. Now we can say those 6 electrons. We can assign 2 bonding electrons per bond. 6 divided by 2 equals 3. That gives us our structure of a single bond between chlorine and sulfur. chlorine and sulfur and oxygen. So we predicted that there would be 3 bonds, and we used 3 bonds, so there's no bonding electrons left, but there are extra valence electrons. We started with 26, we only used 6. That means there are 20 left. So that means we need to assign them as lone pairs, 2 at a time. So to determine who gets the electrons, check and see who has an octet first. So if we take a look, our first candidate for gaining the octet is chlorine. 3 lone pairs around each of the chlorine. So we've got 2, 4, 6, 8, 10, 12. We've used up 12 of our 20. And then we can say, all right, oxygen can also take another 6. And then we've got an extra 2 remaining, and that can go on sulfur. Now we can check the formal charge the usual way, and we determine that sulfur has a +1 formal charge and oxygen has a -1. Those are okay. Now, this brings us to another concept in our Lewis dot diagrams, which we're going to talk about at the end, but we might as well talk about it now. We notice that sulfur has a +1 and oxygen has a -1 formal charge. Since sulfur is in the 3rd row, it can expand its octet. So what does that mean? That means that it can have more than 8 electrons around it. So if we take 2 of oxygen lone pair electrons and put them on sulfur, we have the following structure, where we've got a double bond between oxygen and sulfur, and we've left the sulfur-chlorine bonds the same. Now, if we check our formal charges, we discover that all the formal charges now are 0. So by expanding sulfur's octet, we have all non-number formal charges, i.e. they are all 0. That makes the best Lewis structure because we've managed to have all atoms having a 0 formal charge. There are 2 possible ways to draw the structure, the way I drew it up at the corner, plus the dots. All atoms have a 0 formal charge. That makes it the best Lewis structure. Now for some problems, those are done at the bottom of the video.